evaluate this double integral. This is area of this region. R is 0, 1 through 0, 1. So we can rewrite this double integral is 0, 1 and 0, 1 with respect to x and y. So x e raised to xy dy dx, or dx dy. It doesn't matter. It could be just dx dy. Okay. Now let's try to evaluate this. So this is same as working this first, then with respect to y. But since we can interchange dx and dy, you have to be careful. If we put x first, then we got a product of two functions. This is x, this is also a function of x. That means we got a product, so integration by parts. But if we do y first, let's say here is y and x, then this x behaves like a constant, and we have only one factor of y, and the integration will be easier. Okay, so let's do this, writing y first. So this is same as 0 through 1. Now x behaves like constant, so x no use, just x. Antiderivative of exy, antiderivative of exy with respect to y. X is constant, you can think like 2y. So this is same, and we divide by this constant x. Okay, so here this is exy divided by x, and our y runs from 0 through 1 dx. I'm writing y so that we don't get confused. Okay, now let's evaluate this integral, this limit in fact now. 0 to 1 x times upper limit y equals 1. So this x, so since we are just replacing y, this x can be pulled outside. In fact, we can cancel this x's. Okay, and then we have now upper limit y equals 1, so e raised to x times 1, just e raised to x, minus lower limit y equals 0 here, e raised to 0, which is 1 dx. Okay, now we can integrate easily. Antiderivative of ex is just ex, minus antiderivative of 1 is just x, because with respect to x, and it's from 0 to 1. Upper limit e raised to 1 minus 1, minus lower limit e raised to 0, 1 minus 0. So e raised to 1 is just e, an irrational number, minus 1, minus 1, so minus 2, e minus 2, final.